Thank you for joining us. So today we're going to be walking through some new technologies and how they make automation more accessible and really changing the automation equation. So through technology, projects that even a few years ago were impossible or not cost effective are suddenly within reach, making manufacturers more competitive. And that can be for a couple of reasons, right? Upfront cost reductions in automation, reductions in the lifetime cost of automation. And the technologies themselves are more flexible, easier to use. But either way, these technologies are really changing the way automation is done. I'm glad to be joined today by two subject matter experts. We have Corey Razor, the Business Development Manager from Schunk, a global leader in tooling and work holding, and Gib Gilmore, sorry Gib,
That's all right.
a regional director at Keyence, a global leader in vision. I'm Jake Huckabee, Vice President of Strategic Initiatives at READY Robotics, creator of the world's first universal operating system for industrial automation. So in the webinar today, we are going to look at new work holding and vision solutions combined with software solutions to address a very common problem, inspection. And once we take a look at a demo of these new technologies working together, we'll have a panel discussion where we talk about the technologies, why they matter, and how manufacturers can take advantage of them. And then, at the end, we'll have an open Q&A. So if you do have questions, feel free to drop those in the comments, and we'll address those as they come. All right. So let's get started with the introductions. Gib, would you mind introducing yourself, Keyence, and talking to us a little bit about how Keyence is making automation more accessible?
Yeah, sure. Thanks, Jake. Hi, everyone. Thank you for joining. As Jake said, my name is Gib Gilmore, and I'm a regional director in our machine vision division at Keyence. I began with Keyence 21 years ago and have been primarily involved in machine vision since then. So Keyence, as you don't know, is a global innovation leader in factory automation to quality assurance solutions. We're a direct sales organization with offices all around the world globally to support our customers. And we offer technologies ranging from simple sensing technologies to 3D surface metrology equipment. So the machine vision industry has gone through a lot of changes in the past couple decades, at least while I've been in it. In particular, the past 5 to 10 years, it's been expedited, and some really fantastic technologies are being introduced. So when we used to be able to do only 2D presence absence inspections, 10 to 15 years ago, now we've leapfrogged all the way to critical and complex quality inspections. So at the forefront of some of those technologies that have been improved over the past few years, resolution of cameras have increased greatly at a great price point. Software algorithms are getting more powerful, and specialized lighting is making a big play. So with the high resolution cameras in the market, we're able to offer more accurate gauging and better image quality to improve people's inspections. As well as with specialized lighting, we're able to make the best image possible to inspect. Some of these specialized lighting technologies are allowing us to look at subtle, indistinguishable contrast differences in features that the human eye can't even pick up. So as these technologies increase, companies are doing a fantastic job with product development and bringing the cost point down at the same time. So that, coupled with the flexible integration ease of use for products like READY, Forge OS5, Schunk grippers, Keyence products, we're able to integrate, deploy, and maintain solutions at a much lower price point and time and labor aspect. So that increases everyone's ROI in a very short period of time. So the challenges we have in today's world, as we experienced in the past year and a half, automation is skyrocketing, and we're able to offer cost-effective solutions to customers as their needs change and increase.
Awesome. Thanks, Gib. Corey, would you mind introducing yourself, Schunk, and how Schunk is making automation more accessible?
Yeah, certainly. Thanks, Jake. My name's Corey Razor with Schunk Automation. I've been with Schunk for nearly 4 years now, but have been working with Schunk hardware in some capacity for a total of 7. I've had the pleasure of working on many different end-of-arm tool applications, from material handling, machine tending, various quality and inspection applications like we're going to see today. and it's just been a great ride so far. Schunk is a global family-owned company, and we've been an innovator in the end-of-arm tool world and automation world since the early 80s. We developed some of the world's first standardized gripper products. Prior to this, it was all individual mechanical components, pneumatic cylinders driving rack and pinion type systems that every machine builder or systems integrator had to verify that design kind of on their own. So as we've seen in terms of new technology, what we're seeing, the advancements in the end-of-arm tool world, a lot of tooling, there's several aspects. A lot of tooling on one hand is becoming more intelligent. So we're increasing the functionality and the capabilities, the sensing feedback and data that we can get from these tools to improve your process, to sort of take steps to mitigate issues and things like that. So that's one area that accessibility is increasing, because a lot of the times those new intelligent products are having very intuitive user interfaces so that users can access them quickly. The other facet we're probably going to talk more about today is predominantly the ease of integration, the speed of implementation, and sort of reduction in engineering and design costs, those upfront costs. So we're going to see some hardware today that sort of addresses that.
Fantastic. Thank you. And I'll introduce myself as well. Again, I'm Jake Huckabee, Vice President of Strategic Initiatives at READY Robotics. I have a PhD in robotics engineering and have spent the last 15 years working in robotics, automation, and autonomous systems. I've been with READY for about 4.5 years. Now, READY Robotics is a venture-backed startup company headquartered here in Columbus, Ohio, really focused on trying to revolutionize how automation is done through our flagship software, Forge OS. Now, Forge is a software ecosystem where I can bring together any number of different automation components, from different robots from a variety of different brands and manufacturers, PLCs, sensors, vision systems, tooling solutions, a variety of different automation components together into a single software interface, so that I can program the systems, I can configure the systems, I can control my entire work cell from one place. And with our no-code, intuitive, easy-to-use programming interface, you don't need a PhD to program the automation system. You can upskill really anybody to be able to program the work cell and get it into production very, very quickly. And I am excited to see how these different technologies work together to make automation easier to use, more accessible. And we have a demonstration for that. So to my right here, we have a demonstration where we'll be using brand new tooling from Schunk, new vision solutions from Keyence, all tied together with Forge OS to do inspection. In this case, we'll be inspecting grinding discs. Now, we have a collaborative Yaskawa HC10 robot that we've mounted a Schunk flex grip tooling system to the tool flange. And that's going to pick up these grinding discs and present them to the Keyence CVX400 series controller. And the Keyence system is going to inspect for a couple of key features on the disc. And discs that pass inspection are going to get put into the green bin. Discs that fail inspection, well, they go into the red bin. So let's talk in a little more detail. Corey, you want to walk us through the tooling?
Yeah, certainly. So like you mentioned, we're using a product portfolio called FlexGrip Tools for this demo. That is a portfolio of just a lot of modular, easy to assemble, easy to construct, very adjustable hardware to build up end-of-arm tools quickly. This is incorporating our industry proven and tested standard grippers, so it's product that will work and you don't have to worry about that. And in our situation, we'll see a tool that's quite simple, just a two dual gripper setup, but it doesn't necessarily have to be simple. You could make more complex tools, or whatever really fits your application, whatever your process demands.
Awesome. Thanks. Gib, you want to walk us through the vision portion of what we're going to be looking at?
Absolutely. So, as Jake said earlier, we're utilizing our CVX400 controller, which has 14 core processors in it. What that allows us to do is have multi-camera connectivity, up to 64 megapixel cameras. But more importantly, it allows us to use our specialized lighting. Sophisticated lighting that I touched on. This light in particular offers regular 2D lighting, as well as what we call Lumitrax or structured lighting, or also called photometric stereo lighting, as well as our pattern projection lighting. So what that allows us to do is bring out differences depending on the application as things change. So if you're looking like a black on black differentiation need or a height measurement, this lighting combination can provide all of that, all 2D and 3D inspections at the same time. Thank you.
Awesome, thanks. And I'll talk briefly about how Forge is going to bring these systems together. So with Forge OS, we are going to be pulling these systems together and speaking to them individually as different devices. Let's go ahead and take a look at what that's going to do. All right, so I'm going to get our system up and running. I'll hit the start button here. All right, so now that our robot is moving, you can see our software is running in Forge OS. And we're presenting these discs. So Corey, do you want to talk us through what's happening on the tooling end here?
Yeah, certainly. So like we said, we have this dual gripper setup that we're looking at, and this was really built up of two standard parallel pneumatic grippers, and all the hardware that we see around it is our FlexGrip tool hardware. This is all standard components, standard adapter plates, pre-made adjustable fingers with finger inserts, and all that stuff's off the shelf. So it's very, very quick to get going, and very, very fast to sort of work with your application. In this process, we decided to stick with two jaw grippers for expandability. Right now, we're just inspecting the top of the discs. But if we decided later that we needed to also inspect the bottom of the discs, we could now present the discs in a different way, and instead of ID grabbing the arbors, we could grab the discs from the side or the edge. And that way we could place the discs both front side and bottom side up to the camera as needed. What's great about FlexGrip tools is, because this is so adjustable, if when we were building this setup, we figured out that a two-jaw gripper with its 3 points of contact prongs that we're seeing there in this finger setup, if that wasn't very reliable or it didn't give us a perfect hold, then it'd be very, very easy to switch those grippers out from two-jaw grippers to three-jaw grippers. To that end, if tomorrow we were to move this whole cell to a different part of the plant that did not have an air supply, well, we could easily swap those grippers out to standard electric alternatives to those pneumatic grippers. And then, of course, the last thing is, if next week we're not even doing this process anymore, you can reuse and reconfigure all that hardware for a new task. So it's quite nice. So FlexGrip Tools, this hardware, it's great for anybody that's trying to get set up quickly and running the robot very, very fast. Someone who's new to automation, people that are looking at proof of concept or prototyping, but it's also rugged enough for actual production in lightweight applications. Its adjustability lends well to people that are trying to keep their tool flexible and configurable. So anyone that's sort of living in that low volume, high mix world. In this case, our tool was very easy to set up. I could quite literally come in with the hardware without having built any CAD models or designed any custom adapter plates and we had an idea of what the tool would look like. We built it in about 20 minutes, took maybe another 10 to dial that in and tweak a few things, and then we were up and running. Furthermore, the simple programming that Ready brings to the table really made it easy to teach the tool center points and make adjustments as needed. And correct me if I'm wrong, but you probably had the motions for the pick and place application done within a few short hours.
Absolutely. Yeah, that's great. I tell you, I can't think of the number of times that we ourselves or partners, customers we've worked with have been in that situation of, having to design and then redesign end-of-arm tooling over weeks of time, right?
Yes.
You design, you manufacture, you attach, and then you find out something went wrong.
Right.
That iterative process is...
Exactly. And in an ideal world, every application would have custom fingers, custom adapter plates made exactly for the application. But that takes time, and that takes engineering, and it takes costs. And it's not necessarily a quick process if you do have to adjust things. So this is a really good way to help alleviate some of those pains.
Absolutely. Great. Thank you.
Yeah.
Gib, you want to walk us through the Keyence software and how it's working with what we're seeing here?
Absolutely. Thanks, Jake. Sure. So what we see here is a one-camera setup, a high-resolution camera to assist in some high-accuracy gauging of the part. As you can see, it's fixed mount and presenting the part underneath it by the robot. We also have the option of putting the camera and light on end-of-arm tooling and holding the object of inspection stationary, looking at different angles, all different axes of the product, and get very, very flexible inspection. So in this case, we have the fixed mount camera, high resolution, and then we also have the light, which is a combination of three different lighting technologies: regular lighting, as well as what we call Lumitrax, that helps bring out surface defects or impressions, as well as our pattern projection, which combines 2D and 3D measurement and inspection capabilities. What's important about that is, similar to what Corey was expanding on with the flexibility of the grippers now, going from one application to another, if we use this type of lighting in a robotic application, we can run an assortment of different targets and be able to do different inspections. But say something pops up and we want to add an inspection for something totally different. With these different lighting technologies, we can be completely flexible and adapt on the fly and be able to meet the customer's needs rather than having to buy a whole new system, more hardware, more programming, more runoffs, which is time, and time is money, as we all know. So let me show you what the vision system is inspecting on this part. And when it comes to machine vision, there's primarily 4 inspection types. There's presence absence, there's also gauging, measurement types applications, as well as defect or quality type inspections, and then traceability or barcode OCR reading. So as you'll see in these inspections, the first one is a presence absence. We're just looking for the pattern of the DeWalt logo. So with that pattern, what we're able to do is make sure that the logo is there, it's the right logo, and portions of it are not missing. The silkscreen process did its job. Additionally, as you see, it just rotate, finds a position of that pattern, and then moves all the other inspection tools to a relative position. So it keeps looking at the same inspection regions that we programmed it to. Now, as up here in the diameter inspection, you can see it's reading 114. That's millimeters. Should be about 4.5 inches. So we're measuring the diameter of the part, making sure, yep, it's the right part. It was made correctly. We didn't mix up a different model, and it passes the gauging inspection. Down here, we're looking at the mating surface. It goes around the inside of the grinding disc. And what that is doing is looking for any kind of imperfections, dents, scratches, burrs, to make sure the mating surface is nice and flush and the power tool doesn't have any slippage or breakdowns. And then lastly, as you saw in the barcode region, as you can see, our demo just ran out, but we're going to get going again in a minute. The barcode inspection was not only looking at the 1D barcode, but also reading that out. What's important about that is we can inspect the barcode to make sure there's no mix-ups between the product is supposed to be and what the barcode is being printed. And additionally, another thing that makes machine vision and this type of stuff more accessible is we can take that data from the barcode, as well as an image of the part and any of the other inspection data, maybe a date and timestamp on that information, and send it to maybe an internal database, FTP drive, so we can actually have traceability. And that safeguards you from your customers, as well as helps you re-engineer manufacturing, process flaws or something that's happening upstream to cause a defective product, and you can reverse engineer and figure that product out and fix it. So that's it for the machine vision. I'll pass it off to Jake.
Great. All right. Thanks, Gib. So what we've got, tying everything together with this flexible tooling solution and the brand new vision software and technology coming from Keyence is ForgeOS. And you can see what we're looking at right now here in ForgeOS is the no-code programming environment. And what we're really trying to do here, as I mentioned, is trying to create an environment where somebody that doesn't have background in industrial automation, doesn't have a deep understanding of how to program robots or PLCs, can very quickly get up to speed with how automation systems work and how to program them in production environments and get them moving. So we take a look here. We've got a flowchart based visual programming environment where I've got motion building blocks for my robots, and I've got gripper building blocks for my smart grippers, and I've got building blocks for interacting with my vision system. So I can pull together every device, every component in my work cell and program it from a single intuitive interface. I can come to my device configuration panel and I can add as many devices as my work cell needs. So whether it's a collaborative Yaskawa HC10 robot or half a dozen industrial robots from FANUC or ABB or whoever, combined with smart tooling solutions, combined with vision systems that are going to allow me to interact with my parts and pieces, I can very quickly automate my work cell. And by me, I mean any of my employees. So anyone on your floor can be very quickly trained into how to program the work cell and get it moving in production quickly. And that's that. All right, so this is the demonstration that we have of these new technologies. So what we'd like to do now is really have a conversation about these technologies and how they work and why they're important. So how is new technology like these making automation more accessible, easier to use?
Yeah, sure. I'll start if that's okay. I mean, like we've sort of shown today, there's a lot of standard solutions out there, and we're trying to prevent reinventing the wheel as much as we can with standard adapter plates, standard finger components, and all these things that can help you get up and running quickly, have a faster deployment of your system. So we're seeing more and more standard components developed for complex applications, not just by Schunk, I think by all manufacturers. And then when things do need to get away from that realm of a standard product fits the bill, we're seeing development and processes put in place so that we can output custom solutions faster. So that's things like semi-standard products, resources and configurators that can help you output things and just take some of that engineering workload off of you, the customer.
Yeah, and I guess another point to that is the flexibility that we're actually, the manufacturers are going an extra step further. Instead of coming out with technology that just does the job, they're coming out with technology that does the job, repeats the job, and continues to give constant feedback so we can accommodate and adjust on the fly to where the customer's needs are. So what's beautiful about Ready ForgeOS 5 is the flexibility, integration. I mean, we have a Keyence vision system here. We have Schunk grippers. This is kind of a dumbed down version of a typical application on the manufacturing floor. So as you guys know, there's more needs than just those particular products or technologies. There's going to be needs for safety products. And here we have our Keyence SCD Keyence safety scanner ties straight into ForgeOS 5, as well as sensors, load cells, light curtains, all the types of automation equipment you need in one solution. And being able to deploy that easily, faster you get it to market and get up and running, the better, obviously, to get product out the door. But then on the continuing on, the feedback that these products are coming out with I/O analysis and diagnostics, traceability capabilities, to continue to make sure no one occurs downtime, and they have good throughput, the ROI just continues to go sky high.
Yeah.
Finding out.
Yeah. You made a good point, right? So we as component level manufacturers, we can make our content simple and intuitive to use, but that's still one component of a system.
Right.
There's still room for integration and sort of programming and all that stuff to be simple and room to improve that. And Jake, that's where, as you will explain, that's where Forge comes in. It's great.
Yeah, absolutely. We talk about ROI. We talk about these new technologies, and one of the ways that I think that we make automation more accessible is cost savings, right? We talk about saving with upfront costs because we've got better materials and better devices, so we're driving down costs that way. We've got the lifetime cost savings of using devices in smarter ways, getting feedback from the devices. But you also talk about savings in more the soft costs, right?
Yep.
Your programming times, your downtimes, your maintenance times. And something like Forge OS, by being able to shift the resource allocation from time spent programming my system, my work cell, to process optimization, and programming new processes and things. I think there's really a big cost savings there, on really being able to focus on what you want your employees focused on, which is making more things, right?
Exactly. So some of what you guys are doing and others, you're basically creating packages, kits, bundles of hardware that works well together, and a lot of that stuff can be meant for a specific task, and it's pre-programmed. There's all this sort of code in the background that the end user, machine builder, integrator doesn't necessarily need to worry about. With these packages, we're seeing people basically look at the task and say, okay, don't worry about programming an intelligent smart gripper, don't worry about programming a vision system. That's already sort of been done or will be done. Worry about programming your task. What's specific about your task? We're doing a bin picking inspection task. The parts are roughly this size. The parts are roughly this mass. So that's just another great way that things are being done faster.
Yeah. Well, and like you say, with the ability to kind of abstract away, to hide those nitty-gritty details with smart grippers, with some of the things that we've got with kind of pre-canned task templates. So I don't have to worry about building things from scratch. I can say, here is my inspection task, and just kind of filling in the holes. I think there's a lot of advantage there. And I know Keyence has some great advances there in being able to make things easier to use.
Yeah, we've gone the extra step in the development of our products, and it's not only from our safety scanners that have visual feedback to our vision systems with very intuitive setup GUI front end, as well as I don't want to call them disaster settings, but we have a lot of extra functions when it comes to, you get a camera bump, you lose the resolution or light, being able to document your specific case study or application you're doing. It goes a long ways. And you guys are hitting on fantastic points, and I mentioned this a little bit earlier, and I think a lot of people are starting to realize the value of this type of technology and the flexibility. Unfortunately, we're here where we are in the current day. We've gone through the pandemic. We have global supply chain shortages. We have labor shortages, unfortunately. So to be able to, adjust and adapt to that, and you don't necessarily need a specialist, as Corey is saying. You don't need someone who's worked on robots for 10 years. This type of technology, we're offering technologies to help it get it going, get it deployed, and then maintain it. And I think companies, unfortunately, we had to go through what we did the past year and a half, but they're seeing the real value in that. As long as we educate our customers on that type of technology, what value it can add, it goes a very long ways, and I think they see the ROI on it.
Yeah, absolutely. So talking about the demo that we've got here specifically, you know, how does some of these new technologies translate to other applications or specific, you know, end user needs?
Sure. Yeah. You know, so with Schunk, we see it all the time with end-of-arm tool manufacturers, and not just Schunk. You know, other component manufacturers in the end-of-arm tool space. You know, we're always going to struggle with that component that needs customized. You know, that's always going to take time, and so you know, a system like this, something that is quick and flexible, is really beneficial in that space. Yeah.
Absolutely, absolutely.
It's been exciting because with the progresses in technology, for instance, you take this as a kind of a case study. 10 years ago, if you wanted to do a vision system coupled with a robot, a 6-axis robot, you're talking high upfront cost. The ROI may be, you know, 5, 8, 10 years before you see that. A lot of the robots are in 6 figures starting. So as robot companies improve their processes and development and capabilities, the price point's coming down. And, you know, we've also had the introduction of smaller robots, cobot robots, and our vision systems as well are coming out with more capabilities with maybe lighting or resolution at a lower price point. So when something was a 6-figure solution and some companies couldn't justify the ROI, we're now looking at something that may be, you know, 30, 40 grand. And I've talked to a lot of companies that say, I can see the ROI in that in a year. That's amazing. And the flexibility with the technologies to be able to adjust to any of the changes that they see maybe in their product, their manufacturing process, you know, going from manual to semi-automation to automation, it's all there. So there's no more added cost. Yep. And the, like you guys said, the soft cost of man hours and skill is not needed.
Yeah, absolutely. You know, we've had, you're talking about flexibility, talking about needs of the customers and how technology is changing. We've had a lot of different customers who've come to us and said, you know, before we talked to you, we had some fantastic needs. You know, we wanted to automate this process, but we couldn't justify the cost. You know, bringing somebody else in or doing it themselves. You know, they didn't have the training, they didn't have the skills, and they couldn't afford bringing somebody in to do it. It didn't make sense. But being able to take these new smart technologies and couple them with Forge OS, you know, these customers have been able to train up their entire staff to program these automation systems. You know, and you know, again, across the board, we're talking to these people, and they're just ecstatic, saying, we're so excited because the first day we're able to program our system. You know, look, my robot's moving. Look, I'm able to see things and move things. And in under 2 weeks, they're running lights out manufacturing operations. Yep. You know, I think that, you know, that from a flexibility standpoint, from a you know, cost sensitivity standpoint, these new technologies enable manufacturers to do automation. It finally makes sense to them.
Absolutely. Yeah. You know, you're right. Like that cost point. We've been talking about that the whole time. This reducing not just upfront investment costs, but total cost of ownership, the lifetime costs. You know, that's even areas where more advanced technology helps, because, like we talked about intelligent products earlier, you know, versus simple products, those tend to be a higher initial investment. But the additional functionality, the additional capabilities, the additional data and things you can do with those, and the process, how you can improve your process, ultimately tends to lead to a lower lifetime cost.
Yeah, absolutely, absolutely. So we've got a couple of questions in the hopper here. Briefly, let's see, we've got. the Schunk gripper, is this Schunk gripper collaborative?
Yeah, so that's a great question. This Schunk gripper is not collaborative. In this scenario, while we certainly do have certified collaborative grippers, this was a focus on ease of use, getting a job done quickly. In this sort of case, we could have area scanners and things like that that would make this more of an application that is just simple to use, simple to build.
Yeah, great. Great, thank you.
No, actually, it's not collaborative. Like I said, it's very easy to use on the upfront. Has a lot of tutorials to walk you through, even in the program itself. Some examples, some case studies and such. So we try as much as possible to add the intuitiveness into the programming of the system. So anyone of experience levels in beginning with machine vision till experts have the capability to program the system. So
Awesome, thank you.
sure.
Let's see. Average selling price of a robot is greater than $100,000. So, question about prices of robots. And the answer is it's going to depend. I love that answer. It depends on your needs, right? You can have robots as cheap as $10,000, $15,000 all the way up to $100,000+. It's going to depend on your application. It's going to depend on your needs.
Yep.
And what I will say is that with a solution like ForgeOS, combined with these smart technologies, you're able to pick the hardware that makes sense for your application. So, you don't have to feel like you're stuck with the $100,000 robot. Maybe you can use the $20,000 robot because it's a better fit. It makes sense, and not have to worry about the overhead of getting into that. And again, these smart technologies working together, I think, makes applications possible where before they just weren't.
Yep. Completely agree.
All right. Okay. Sorry. One more question. How much detail can you see on that Keyence camera?
So in particular, this is a 2 megapixel camera. So, like that barcode, the narrow width bar measures about 1.1 millimeters in the camera. So as I said, we go all the way up to 64 megapixel cameras. So starting from VGA, we offer 2 meg, 5 meg, 21 meg, and now 64 meg. So when you get to the high end, it gets very cost effective because you can see very, very, very high accuracy. And it's a matter of taking your field of view and your pixel count and dividing to find out how tight you can see, how tight tolerance and accuracy you can see. But the more important thing is we've been talking about cost a lot, is our 64 megapixel cameras are the first that I know of off the shelf non-PC based systems. So they're extremely fast. You don't need a computer or PC to hook it up to and program it. So that definitely cuts down on hardware cost and programming time.
Great. Thank you.
Sure.
Yeah, no comment to that. Yeah.
All right. Well, that brings us to the end of our time today. Special thanks to Gib for joining us from Keyence.
Absolutely.
And from Corey from Schunk.
Yeah, it's great to be
Enjoyed
here.
it.
Yeah, you guys are without a doubt at the forefront of innovation, so very great to be here.
Yeah, I'm very impressed with your technology and the development you guys have brought to the market. So I love the flexibility and be able to bring all the different flavors together with a system that's easy to program. So thank you.
Thanks.
Yeah. Well, we've had a great time being able to show you these new technologies and how they work together to make automation more accessible, easier for you to use and deploy in your own facilities. If you've got questions, feel free to visit our websites, keyence.com, schunk.com, and ready-robotics.com. Have a great day.
Thank you.